Hey guys, so in this set of videos we are introducing vectors. Now we'll introduce the vector product, okay, which is also called the the cross product. Okay. Now let's again take two vectors. One vector A is axi hat plus ayj hat plus az k hat. Okay, these are again the components of the vector, and I hat, j hat, k hat are unit vectors. And let's take B as bxi hat plus byj hat plus bz k hat. Okay. Now the cross product, let's first again look at one definition of the cross product. Okay. It's given by A cross B. The magnitude of A cross B is given by AB, and then sine of theta. And you can also write this as like A cross B is equal to AB sine theta with some unit vector n hat, some direction. Okay. Now these are again two vectors that are like pointing in some direction. Okay, so let's say this is A, this is B, and theta is the angle between the two vectors. Now before moving on to the definition, to the next definition, again the motivation as we did for the dot product. So the motivation for this is that there are quantities in physics that are given by the cross product. One of them is, you might know about it, it's the torque. We have defined torque in one of our videos. So torque is R cross F. And another quantity is the magnetic force on an object. That's given by the charge on the particle times V cross B. So these are the physical motivations of the cross product. Again, this is another way to multiply vectors other than the dot product, and has physical applications. Now the direction, so now again, why is this called the cross product, the vector product? Because you get a vector when you perform this product. You get a vector which has direction and magnitude, and the other name cross is because you put this cross. So whenever you see this cross, you should know that it's a cross product, and you should get a vector with a direction as the answer. Okay. Now now looking at how to get the direction of the cross product, right? So there's one trick that's used, which is called the right hand rule. Let's say you have two vectors. Let's draw big vectors. So let's say this is A, this is B. So if you want to find where the direction in which A cross B point, you will point your fingers towards the direction of A and then cross towards B. So you have to orient your hand in a way you can, so that you can cross towards B. Okay. So you cannot do this, because then you won't be able to cross towards B. You have to do it like this. So you point your finger towards A and then cross towards B, and then your thumb will point into the page. Your thumb will point in the direction of the cross product. So A cross B is into the page. Okay, is into the page or screen, right? And if I want to do B cross A, what I'll do is, you want to point towards B and then cross towards A. So then your thumb points out of the page or out of the screen, right? So then B cross A. Okay, so B cross A is out of page. Okay. So that's how the right hand rule works. This is the right hand rule. Okay. Let's go back to what we were doing over here. Now looking at this definition, okay. Now let's look again at the unit vectors. So the unit vectors, in order to get the second definition of the cross product, we have to first analyze the unit vectors. So we have I hat, j hat, and k hat, right? So x, y, z directions. Now I hat, the vector I hat points. So let's say that you have a situation like this, right, where I hat points at one corner of the page, j hat. So this is your x direction, this is your y direction. Now you will again point your fingers towards I and then curl towards j, so you point out of the page again, right? So that's your k hat direction, right? So when you do I cross j, let's look at this definition, right? This one. So you got I cross j is equal to the magnitude of I times the magnitude of j times the angle, sine of the angle. Now the angle, they're perpendicular to each other, so the angle is 90 degrees, so you get sine 90. And then again, when you do I cross j, you point towards the k hat direction. Your thumb points towards the k hat direction, which is the z direction. So this is 1, this is 1, this is 1, so you just get k hat. Right? So I cross j is k hat. And if you do it the other way, if you do j cross I, right? So if you do j cross I, you get j, and then you curl towards b. You point your thumb points into the page, so that gives you negative k. So j cross I is negative k hat, right? So you can get all of the cross product equations for the unit vectors by using one simple trick, by noting that there's the cross product is cyclic. So you get I hat, j hat, and k hat. So I cross j is k, k cross I is j, j cross k is I. Okay. So if you want, we can write that down. So let's write that down. So j cross k is, we have I cross j over here, that's k hat, and j cross k hat is I hat, and k cross I is j hat. So k cross I hat is j hat. Okay. Now if you go the opposite way, like if you do j cross I, you get negative k. So if you go in the opposite direction of the cycle, then you get negative sign. So j cross I is negative k, k cross j is negative I cross k is negative j. Okay. So if you let's write that down so that we have everything with it. So k cross j hat is negative I hat, and I cross k hat is negative j hat. So and when you take the cross product of the vectors themselves, so I cross I, now you're taking the cross product of the vector itself, they point in the same direction, theta is 0, so sine 0 is 0, so you get 0, the null vector. So you get 0 for this, then k cross k is also 0. Okay. So we have all the these relationships. So the way I'll write down the cross product of these two in terms of these components is that I'll use the matrix, which what you do is as follows. Let's say you have A cross B. I'm going to do it using a trick, if you want to call it that, but it will give you the same answer. It's just a convenient way of getting the cross product. So you can do it one by one also. Now you have all the rules. You have all the rules on how the unit vectors multiply. You can do it one by one also, right? But we're going to use this trick. That's very useful. Once you get used to it, I'm sure you will prefer this one, right? So bx, by, bc. Okay. So when you want the I component, right? Now what you'll do is, so the trick is that you will cover this guy, and then you'll cover this guy. Okay. So let's use cover this guy. And then you'll just take the determinant of this matrix. So you'll only take AY, AZ, and then BY, BZ. Okay? And then for the J hat, you'll put a negative sign over here. Okay? And why do we put the negative sign? Because this gives you the right cross product when you do it one by one. Okay? When you do it one by one, this is the only way you will get the right answer. Okay? Which agrees with that. So that gives you this matrix, this one and this one. So J hat is AX, AC, BX, BC. Okay. And then K hat will be this. You're covering this one, this column and this one. So you get AX, AY, and then BX, BY. Good. So now the determinant, if you have seen this, the determinant is obtained for a matrix, for 2 by 2 matrix, when you multiply these two and then subtract it from the product of these two. So you get I hat as AY, BC minus AC, BY minus J hat, AX, BC minus AZ, BX plus K hat, AX, BY minus AY, BX. So that's your cross product, A cross B. Okay? Now again, if you do it one by one, okay, you'll get the same answer. This is just a trick. Some students always ask this question, right? You know, why are we doing this? This is just a trick, and especially this negative sign is always a source of confusion. Why do we have this negative sign? Again, we have this negative sign because if we do it one by one, the signs agree with this trick. Okay, so let's double check some signs. So let's say that we're gonna check the I sign. So I is when we do K cross J. So let's cross this with this. So AYBZ, right? AYBZ is J cross K. So J cross K gives you I hat. So you should have a positive I hat. So J cross K again gives you AYBZ. J cross K is I. So you get that. So AYBZ J hat, I hat. Okay. Now let's confirm the sign of one of the J's. So J is when you cross K and I. So let's cross this K with this guy. Right. So you get AZBX K cross I. So K cross I is where's K cross? K cross I is J hat, right? So K cross I is J hat. So that's what your so K cross I is J hat. So you get a plus sign. So AZBX is a plus sign. So you can see that it's a plus sign. But if we don't put that negative sign, then we get a negative sign from this trick, and that you disagree with the actual cross product. Okay, when you do it one by one. So that's why this equation is useful. This trick is useful to get the right answer quickly. Let's go back to our example. This guy, right? So let's let's quickly work out an example where again you have A as 2I hat. Our standard vectors, like we've been taking the same example for the addition and then the dot product. Now let's do the cross product for this guy also. So A is 2I hat and B is 2I hat plus 3J hat. Okay. Now if you do A cross B, so let's do it one by one. So when you do A cross B, you get I cross I. So this is 0, and this gives you K hat. I cross J is K hat, right? So you get 2 times 3, which is 6, and I cross J hat. So that gives you 6K hat, okay? And the magnitude of the cross product is also, it's just, the magnitude of cross product is just 6, okay? Now if you use the matrix trick also, so remember one of the things that students make a mistake on is that when they do the cross product, okay, if they see now for the cross product, you have to write each component. There's no other way. You have to write each component. Okay. So when you do A cross B, you would do I hat, J hat, K hat, and then you would do 2 0 0 and then 2 3 0. You have to write the K component also. Otherwise, you won't be able to do this. You won't be able to perform this trick. Okay. So then you can see that the only non-zero component, so this matrix has 0 determinant, this also has 0 determinant, this is 6 minus 0, so you get k hat 6 minus 0, which is a 6k hat. So this is a vector that points out of the page, so it is A cross B, which points out of the page and has magnitude 6. So this is it for the cross product or the vector product. Hope you liked the video. If you have any questions, post them in the comments, and please subscribe.